Professor Kitagawa, thank you very much for your time. It's a great honor to welcome a Nobel laureate to the 24th International Conference on Organic Synthesis here in Łódź University of Technology in Poland. Today I would like to ask a couple of questions about your groundbreaking science and your journey. This will be a great inspiration for our listeners. So if you're ready, let's begin. Traditional chemistry builds complex molecules, but you created empty spaces called MOF cages. How do you explain this concept to a non-scientist person?
This is quite a new system. We can construct porous structure from the beginning. I mean, we can design this kind of structure just like building blocks and Lego. So this is very important. So far, the porous materials we have activated carbon, zeolites. It's very difficult to design and directly synthesize the structure we want. But we can do this. This is constructed from organic molecules. So as you know, Aristotle said, nature abhors vacuum. Nature dislikes vacuums. The porous structure is not stable. So against this notion, we try to get this kind of materials. So ultimately we get it from organic molecules. I produce new materials. This changes the structure, the shape, depending on the guest molecule and the external stimulus.
Exactly.
So
They
there
say
are many
it
concepts.
can breathe.
Yeah, many concepts. So thanks to these properties, we can apply this material to the gas substances. Still, we don't have the good technologies to handle gas substances. MOF is very light materials and a lot of the space to accommodate gas substances. So we can produce the storage system and the separation systems. That's a very beautiful scenario.
What is currently the biggest challenge in designing such smart materials?
Flue gas contains 15% CO2, but air contains 0.04% CO2. It's very difficult to capture CO2, but presently we can capture easily. But the problem is how to remove the captured CO2 without the high energy. For instance, in the capture CO2 and release CO2 with high energy. So that means a certain CO2 captured and produce a lot of CO2. So it's a very bad balance.
Yeah.
So MOF can capture CO2 with low energy and also release CO2 in the low energy. Now we are standing at using the CO2 from air. So this is a very big challenge. The second one is all over the world. There are many chemical species in the low concentration. We have to capture low concentrated materials and reuse just like a circulation that way. So there are many targets using MOF and the related compounds. Okay, this is our mission.
You said your frameworks can act like miniature reactors for
Yes.
Or filters, right?
Yeah, and the MOF cannot do everything. MOF can accommodate and concentrate gas substances.
Right.
So MOF can give the good reaction field.
How will they help us solve current environmental and energy challenges in the future?
The big issue is MOF is only 30 years old. It's very difficult to direct application. Now, in the stage, there are so many startups.
Right.
The startups, they have a mission to set up and scale up and also the cost down. So in the near future, we can do it, but still the cost issue is big. So most of the big companies do not want to use MOF.
Right.
Just the looking and waiting for the cost down. As a scientist, we are looking for the future in the 50 years, 100 years.
Yeah.
That's very important. The collaboration is very important.
Imagine that we are in 50 years from now to the future, what we could use from your technology.
Dream is, so far all culture depends on the digging in the underground. We need underground resources.
Yeah,
so the digging culture. So in the future is just I said in air separate CO2, that separating culture. So the digging culture to separate culture.
a new history of human being.
Yes.
Many young scientists will watch this video. Given your Nobel Prize journey, what is your single most important piece of advice for the next generation?
The curiosity is very important. I am the scientist and also the focusing on the fundamental science. So curiosity is very important. So please prepare this kind of curiosity. He said, prepared mind is very important for a young age.
That's wonderful. Thank you very much, Professor, for this. It's a great honor for me to speak with you. Thank you very much.
Thank you.